All right, so now let's take a look at some situations with equations and graphs and determine if they represent a decay model, a growth model, or maybe in some cases neither. So first thing is there's some important information here. If we're trying to determine if something is growth or decay from an equation, the best way to remember is that if b is less than 1, it's decay. If b is greater than 1, it's growth. For graphs, an easy thing to remember is if the graph goes away from the x-axis, it's growth. That means it can go up above the x-axis, but it also means it can go below the x-axis. If the graph goes towards the x-axis as an asymptote, that's decay because that means it's getting closer and closer and closer to it, but never actually getting there. So let's take a look at our first one. We have y equals 1/2 times 2 to the x. We want to check, make sure it's in the right form. It is. 2 is greater than 1, so this would be growth. In the second one, we have 2 times 1/2 to the x. So here we look at the 1/2. 1/2 is less than 1, so that would be decay. All right, let's transition to some graphs. So if we look at this graph, we can see that we're getting really close to the x-axis, okay? Which means the numbers are getting infinitely smaller and smaller, so this would represent decay. Now, in the next one, we see that it's getting infinitely bigger. It's getting bigger and bigger, and we can assume it just keeps going this way, so this would be growth. Okay, the next one, some students want to say decay because it's going down, but it's getting bigger and bigger and bigger and bigger as it goes down. So because of that, that shows growth. Now, the next one is debatable. Some of you could debate, and you could say that there is an asymptote at the point y equals 1. Okay, and if you were to say that, then I could understand why you'd say decay. But because we can't make that assumption here, I'm going to say it's neither. All right, I'm going to say that we don't know if it's going to get to that y equals 1 point. We don't know if that's really an asymptote, so we can't make the assumption. All right, now let's take a look at y equals -2 to the negative x power. Now we need to write this as y equals a times b to the x, not to the negative x. So we need to rewrite this as y equals -1. But how do we get rid of 2 to the negative x? What you do to get rid of a negative exponent is you flip it. So this becomes 1/2 to the x. Now we go from a situation where we thought b was 2 to a situation where b is actually 1/2. So this is actually decay. All right, same concept for y equals 0.4 times 7/10 to the negative x. You can't have your negative x. So just like the last one, we have to flip it to rewrite it as 0.4 times 10/7 to the x. Now 10/7 is greater than 1. Because it's greater than 1, this is growth. Now, there are 2 more problems on here to do, but as I'm looking at it, I don't think we're going to have enough room to write it. But you can see that this one's going up, so this would be growth. Here, this isn't even in the right form, okay? It's not a times b to the x, so this would be neither.